The Rutherford-Bohr atomic model is used to represent the number of protons and the distribution of electrons on the electron shells in an atom. To represent an atom according to the Rutherford-Bohr model, certain rules must be observed when distributing the electrons. The first electron shell contains a maximum of 2 electrons. For elements with an atomic number of 20 or below, the subsequent shells contain a maximum of 8 electrons. And all shells must be filled to the maximum except for the last one, which may be incomplete. Let's see how to do this in a few steps. First, determine the atomic number of the atom you want to represent. This number indicates the number of protons in the atom. For example, a beryllium atom has 4 protons. Draw a circle representing the nucleus and indicate 4p plus for protons. Then let's determine the number of electrons. In a neutral atom, the number of electrons is equal to the number of protons and the atomic number. Therefore, beryllium has 4 electrons. To place these electrons, first let's fill the shell closest to the nucleus. Since we know that it holds a maximum of 2 electrons, we place 2 electrons there. There are still 2 electrons left. We move on to the second shell. Since it holds a maximum of 8 electrons, we can place the remaining 2 electrons on this shell. That's it. The 4 protons and 4 electrons of the beryllium atom are distributed properly. There is another method for drawing an atom using the Rutherford-Bohr model. It's based on the period and group of the elements. Its position in the periodic table tells us about the number of electron shells and the number of valence electrons. Let's do an example with phosphorus. We start in the same way. The atomic number of phosphorus is 15. It has 15 protons. We draw the nucleus with 15p plus inside. Since it's a neutral atom, there are also 15 electrons to place. The period number of the element corresponds to the number of electron shells. Phosphorus is in the 3rd period, so it has 3 electron shells. These are drawn around the nucleus. The group number of the element corresponds to the number of valence electrons, which are the electrons on the last shell. Phosphorus is in the 5th group, so it has 5 valence electrons. We can place them on the last shell. Finally, we fill in the lower shells. The first shell holds a maximum of 2 electrons, and the second shell holds a maximum of 8 electrons. Let's double-check our representation according to the Rutherford-Bohr model and make sure that all 15 electrons are placed correctly. We ensure that the rules are respected. There are a maximum of 2 electrons on the first shell, a maximum of 8 electrons on the subsequent shells, and all the shells are full except for the last one, which may be incomplete. The phosphorus model is correct.